Okay, this is MAP4C day 29. We spent a couple of days working on some technology stuff, and now we're sort of getting ready for the final plunge for the unit. And this lesson is going to set up the practical project and give you a chance to think about the test as well. So the goal, which was last days, not really last days, but a couple days ago, to use the TI-83 to generate a line of best fit. A is to draw a scatter plot, and I cheated a little bit. I drew it beforehand. Notice that, watch your scale. Each tick's supposed to be worth the same amount, and that's the scale I chose. You could probably choose some other scale that's pretty good. It's a bit strange because some of the numbers are so big compared to the other numbers. Probably a break in the graph's not appropriate, but there's the scatter plot. Use the graphing calculator to generate an equation for the line of best fit. Write the equation in this space. Okay, well, I think that's it right there. Let's find, I got two calculators going here. This is it, I think. No, that's not it either. Let's check this one out. There it is. Is that the right data? Yeah, there's the 510. I was looking for the 510 and I couldn't find it. Okay, and so I entered the data real quick, and then remember the steps for line of best fit: stat, calc, down to linreg. And then if I just press enter, it's going to give me the numbers in list 1 and list 2, but I'll go through the steps here. That puts it into the Y-var, so it'll graph it. I don't think it asked me to graph it, but we'll do that anyway just to practice. We see there the line of best fit is negative 20.8 is the slope. And 309 is the y-intercept. Now, of course, we see this one. This isn't linear data at all. I can see the line of best fit with a y-intercept of 309 would go somewhere down here and then down this way, but this isn't a very good model because this data is actually not linear, right? But that's okay. Think of a situation that could be represented by this data. So we want to think of what this variable should be so that when it goes up, the output goes down by a lot. And we can think about this, but my favorite one is if this is number of workers. So X is the number of workers. And then the output is hours to complete the job. Hours on the job. Because if I had more workers, they could complete it faster and much faster, right? So that means it would make sense that it would go downhill like this. Is number of hours to complete job. And you could probably think of other ones that match this this deal. Predict what the y value would be if x equals 6. Now, notice our line of best fit. Did it ask us actually for a line of best fit? Nope, we just had to write it, but our line of best fit would be, something like that, 2 above and 3 below, not bad. And I know from doing the regression on the calculator that the y-intercept is about 300, so that's not bad, in around there somewhere. And then if I wanted to get the value when x equals 6, and since that's among the data, this is an interpolation. And it looks like it's, well, that's 100 there, maybe about 175. So if we had 6 workers, the job would take 175 hours. Notice that that doesn't, that's a way overestimate, because if I were to use a curve of best fit, I'd bounce off over here and it'd be way less than 100. These curves of best fit is chapter 5, not till chapter 5. So that's all good. Now today, what are we up to? I should put a title, but I'm moving on. Conducting an experiment. It says collect, organize, and store 2 variable data from primary sources with and without technology. And our textbook goes through a process used to pose problems, plan a solution, collect and analyze 2 variable data to solve the problem. We're going to use a similar process using our census at school data. So hopefully you filled that out. Hopefully I've given you a sheet of paper with everyone's data on it. Obviously I don't have that data now when I'm making this video, but this is from a class a year ago or a couple of years ago, and we're going to use this data. So what does it say? Step 1 is to plan a conjecture. A conjecture is a prediction about a relationship without much evidence. This is a guess at a relationship. And the idea of planning an experiment is we choose what variables we want to have related. I'm going to pick, just because of the first 2, I'm going to pick these 2. When you get to your project, you're going to get to pick any of these, and what's the relationship between any of these, and you'll get to be creative and choose that. But I'm going to pick the first 2 just because they're the first 2. So variable 1 is going to be the height in centimeters, and variable 2 is the arm span in centimeters. And the conjecture, we believe that as we always read the independent variable going up, as height increases, arm span is going to, what's it going to do? Well, it's going to increase, right? That's what we would guess. And why would we guess that? We believe this is true because taller people have longer arms, right? It wouldn't make sense that if that wasn't the case. Okay, so that's step 2, or step 1. Step 1 is the conjecture. We have step 2 is here, developing a method. We will collect data for variable 1 by measuring, and this could be anything, right? We could do an experiment. We could find data on the internet, but we just measured, and then we use the census at school data, right? Census at school. And this was the same thing. It was just a measurement. Materials needed. The materials we will need for our experiment, well, we already did it, but we had a tape measure, computer, and this is very sciencey, but we would list all the things that we needed. If you plan some sort of experiment that had, ice melting or something like that, you need a thermometer or whatever. Write a plan. Step 4, write a plan. Your plan includes the 3 steps above. Step 4 is a formal way to organize and record your plan. We will skip the step because we've done it above. So the idea is this step 4 is something from your textbook, but we've kind of written it up already on this sheet of paper. Step 5, conduct your experiment. Collect your data on a separate piece of paper. So the idea is if we're going from scratch and you've made your plan, well, then you actually have to go through and melt your ice or do your measurements or whatever, but we've kind of already did that. And it says collect your data on a separate piece of paper, attach it to this plan. So the idea is you're going to choose your variables from the data that we collected from the census of school, and you're going to write them out in a table and include them. Notice that I already did the scatter plot, cheating again, of course. Calculate the equation of the line of best fit. Well, I'm going to do a tight loop and then a line of best fit. Notice I can't use the y-intercept from here because I got breaks in the graph. So I'd have to, if I wanted to, pick a couple of points that are on or close to on the graph, and then use y equals mx plus b and go through that process. I'm not going to worry about that because this is previous videos. If you have trouble with that, look back or ask in class. But what I have done and what you should do is also use a calculator or a spreadsheet. So here, calculator, I got, I think, all of the heights and arm spans written in there. And I'm going to go calc, lin reg, run that, and then I've got my line of best fit. I've got y equals almost 1, eh? It's almost slopes 1. 0.998. I'm just going to write that as 1.0. And then what's the y-intercept is negative 0.7. There's your line of best fit. And there's our analysis. And we've been practicing this all chapter. So we found that. What did we find that? We found that as height increases, arm span increases. Right? And we saw that both from the line of best fit had a positive slope. When I looked at the correlation coefficient, see, the correlation coefficient was very high, 0.9, very strong relationship, even though some people's data was spread out. It's pretty high correlation. And then, was this what we expected in step 1? Yes. Now you're going to pick some weird stuff, I hope, and have fun with this. And so this might not be. Yes. And then repeat the above process for an experiment of your design on a separate sheet. So I'll give you another copy of this, and it'll be your choice. And this is part of the assessment for this unit. This is, will take place of some of the test. All right. Okay. Well, have fun with that. The line of best fit and regression on the calculator.